So that made perfect sense, didn't it?
Yeah.
So, generally the first time we look at quantum stuff or whatever, you're like, what? And it'll probably continue to be that way for quite some time. So, what he's saying here is that when you observed it, it changed its behavior. Now you can think of that very simply. Think of this example. Let's say that you have a boyfriend or a girlfriend, and you go out on a date with them. You go out and you do whatever it is y'all people do. And then you go home, okay? So stuff occurs on the date. Let's not get into any details. I really don't know. But stuff happens, right? You go out, you like them, whatever, okay? Let's pretend like they actually like you too, right? Now, imagine that. Now contrast that with the same events, okay? You're going out with the same person, but your mother comes along. Is that the same date?
No.
No, probably not. For some of you it might be, but I'm willing to bet for most of you it's going to be different. You're like, Mom, can't you just go away? Well, I drove you here, so I'm going to watch this movie too. The whole point is that when you're being observed, you act differently. Does that make sense?
Yeah.
At least when you think you're being observed. And so you can kind of see what's going on here with the electron. Now the difference is, is it an actual person? No, so how can this unthinking, this just object, act differently?
Could it sense the electrons or atoms that make up the other object that are watching it, and then have a reaction based off that?
Yeah. And so, yeah, so you can think about it like that, exactly like he was explaining there. But basically what happens is it's this uncertainty principle that we just talked about. The more accurately they knew its position, the less accurately they knew its velocity. And so by observing it, by looking at it, by taking a measurement, you change what it's doing, which is why the uncertainty principle holds. Okay? Because think about it. Like if I take a picture of, let's say, an electron moving through space, I just take a picture, click, I will have a picture of exactly where that particle is. You know, with me? But here's the thing, if I give you a picture, let's say I just give you a picture of a car going down the road. Like, here's a picture of a car. How fast is that car going? Do you have any idea? You have no idea because it's moving, sure, but if your shutter speed's fast enough, nothing will even look blurry. And so you're like, well, the car's definitely moving. At least I hope. I mean, I hope it's not sitting in the middle of the road. But you have no idea how fast it's going. Now, here's the difference. When you take a picture of an electron, you can actually add energy to it or take energy away from it. You can actually add velocity or take it away in terms of kinetic energy. And so if you took a picture of the electron, sure you know exactly where it was, but you have no idea how fast it's going. You kind of see how that works?
Yeah.
Okay. So, this usually brings up another concept, which I forgot to bring up the video for. And this concept is called the